In this video, we're going to talk about how to write equations of parallel lines. So parallel lines are two lines that will never intersect. So if you look at this picture, it shows you an example of parallel lines, and notice that even if these lines go on forever, they will never cross. So parallel lines have the same slope. So here's two parallel lines along with their equations, and notice that the slope of both lines is exactly the same. The slope is 2/5 for both of these lines. So in this problem, let's look at different equations and try to identify which lines are parallel. So we have equations that are given in slope-intercept form, y equals mx plus b, and we also have equations in y minus y1 equals m times x minus x1, which is point slope form. So we're going to look at the values of m and make sure that they're the same in order for the lines to be parallel. So in the first equation, notice that the value of m is -5. In the second equation, the value of m is 1/2. In the third equation, the value of m is -5. And then in the fourth equation, the value of m is 1/2. So from this, I can say that A and C are parallel, and also B and D are parallel lines. If you would like to do so, you can actually graph these lines and see that they are in fact parallel. So now we're going to work on writing the equation of a line parallel to a given line that passes through a given point. So what's going to happen is we're going to be given the equation of a line. Usually it'll be in y equals mx plus b form, and then it'll give us a point, xy. So we're going to write a line parallel to this line, and then that passes through this point. So once again, we have two ways we can do this. Okay, so you can pick your favorite method. You can use slope-intercept form, or you can use point-slope form. So either way, we're going to start off by identifying the slope of the given line. So in this case, we don't have to calculate slope. We can actually identify slope from the equation that's given to us. Then we're going to plug the slope and the coordinates of the point into either point-slope form or slope-intercept form, and then we're going to work with the equation to write the equation of the line. So remember, you can choose your favorite method to solve these problems. In a lot of the examples, I'm going to show you both methods because I just want you to choose the way that you prefer. So here's a fully worked out example for method number 1 that you can go back and refer to when you're working on your homework. Here's a fully worked example for method number 2 that you can come back and refer to later on. So in this problem, let's try identifying the equation of a line parallel to y equals 2x minus 3 that contains the point -2, 1. And remember, we're going to write the equation in slope-intercept form. So step 1 is to identify the slope of the given line. So the line that I'm given is y equals 2x minus 3. And remember, from y equals mx plus b, I know that the value of m is 2. So I know that m equals 2. So now the slope of a parallel line, okay, is also going to have the same slope because parallel lines have the same slope. So I'm going to use method number 1. So I'm going to use slope-intercept form. So I'm going to go to y equals mx plus b. I'm going to plug in this value of m along with the point that I'm given. So the point tells me an x value and a y value. So I have 1 equals 2 times -2 plus b. So when I do this, I have 1 equals 2 times -2, which is -4, -4 plus b. So now I need to solve for b, so I'm going to add 4 to both sides. So I'm going to add 4 to both sides, and then I get 1 plus 4, which is 5, equals -4 plus 4 cancel, and then I have 5 equals b. So I have b, and now I have m, so I can write the equation as y equals 2x plus 5. Okay, so if this is how you prefer to do this problems, you can skip ahead and go to the next example. So I'm going to show you how to do this problem using method 2. So in method 2, we're going to use point-slope form. So once again, we're going to start off identifying the slope of the line. So since we have y equals 2x minus 3, that tells me that m equals 2. So I have m equals 2, and I have the point -2, 1. So I'm going to call this x1, y1. So I'm going to plug into y minus y1 equals m times x minus x1. So when I do this, I get y minus y1, which is 1, equals m, which is 2, times x minus -2. So now let's simplify this. I have y minus 1 equals 2 times x minus negative will become a plus, so I have x plus 2. So now I need to write this equation in slope-intercept form. Okay, so I'm going to rearrange this equation. Remember, I start off by distributing the value of m. So I get y minus 1 equals 2x plus 2 times 2. So that means y minus 1 equals 2x plus 4. So now remember, in slope-intercept form, y is by itself, right? I want to get y by itself on one side of my equation. So since I have y minus 1, I'm going to do the opposite, and I'm going to add 1 to both sides. So when I add 1 to both sides on the left side, I get y equals 2x, and then I have plus 4 plus 1, which is 2x plus 5. So that is now the equation of this line in slope-intercept form. So once again, I'd like to point out to you that no matter how you do this problem, you end up with the same equation. Okay, so either method 1 or method 2, whichever way makes the most sense for you. So now let's write equation of a line parallel to y equals negative 1/3 x plus 6 that contains the point 3, 1, and let's write the equation in slope-intercept form. So we have y equals negative 1/3 x plus 6, so the value of m is negative 1/3. Okay, so m equals negative 1/3, and then 3, 1 is now my x and y value. Okay, so I'm solving this problem using method 1, so you can skip ahead if you prefer to use method 2. So I'm going to write y equals mx plus b, and I'm going to plug in the values that I have. So I have 1 equals negative 1/3 times 3 plus b. So when I simplify this, I get 1 equals negative 1/3 times 3, so that's 3 over 1. So the 3's cancel, and I have negative 1 plus b. So now to solve for b, I'm going to add 1 to both sides. So when I do that, on the left side, I have 1 plus 1, which is 2. And that equals negative 1 and plus 1 cancel, so I have 2 equals b. So I have b and I have m. So when I write in y equals mx plus b form, I'm going to have y equals negative 1/3 x plus 2. And that is the equation of my line. So let's do this problem using method 2. So remember, once again, I always start off with my slope. So I have y equals negative 1/3 x plus 6. So I have m equals negative 1/3. So the point 3, 1, I'm going to call x1, y1, because now I'm going to solve this problem using method 2. So I have y minus y1 equals m times x minus x1. So y minus 1 equals negative 1/3 times x minus 3. So now let's go ahead and distribute so that we can simplify this and turn it into slope-intercept form. So I have y minus 1 equals negative 1/3 times x, so negative 1/3 x, minus negative 1/3 times 3. So that times 3, I'm going to put it as 3 over 1 because I'm multiplying by a fraction. So I have y minus 1 equals negative 1/3 x minus, so negative 1/3 times 3, the 3 and 3 cancel, so I have negative 1 times negative 1, which is negative 1. So I have y minus 1 equals negative 1/3 x, minus negative will turn into a plus, so I have negative 1/3 x plus 1. Now finally, to get this into slope-intercept form, I need to get y by itself, so I'm going to add 1 to both sides. So that will give me y equals negative 1/3 x plus 2. So notice once again, my equation is the same no matter which method that I use. So now let's write in slope-intercept form the equation of a line parallel to negative 3x plus y equals 1 that contains the point 4, 2. So in this problem, they get a little bit tricky because normally we just look at the equation and we can figure out the slope. Well, in this case, it's not in y equals mx plus b form. So I can't just look at the equation and figure out the value of the slope. So what I need to do is get it into slope-intercept form before I can write the equation. So I'm going to actually add 3x to both sides. And when I do that, I get y equals 3x plus 1. Now I can look at this equation and tell you that the value of m is 3, right? So I have m equals 3. So in this problem, I'm just going to choose my preferred method of doing this. I actually prefer to do them using method 1, which is slope-intercept form. So I'm going to take 4, 2 and make that xy. And then when I plug in, I get y equals mx plus b. So I have 2 equals 3 times 4 plus b. So I have 2 equals 12 plus b. And then to get b by itself, I'm going to subtract 12 from both sides. And when I do that, on the left, I have 2 minus 12, which is negative 10. And then I have negative 10 equals b. So I have b and I have m. So I can write in y equals mx plus b, substituting in these values, which gives me y equals 3x plus negative 10. And remember, the plus negative I can rewrite as a subtraction sign. So I have y equals 3x minus 10. So another thing that comes up in this section is vertical and horizontal lines. Remember that vertical lines have an undefined slope. Horizontal lines have a slope of 0. So when we talk about parallel lines, 2 vertical lines will always be parallel. Similarly, 2 horizontal lines will always be parallel. So if we're going to write the equation of a line parallel to x equals 2 that passes through negative 4, 5, let's think about what we're going to do. So if we're talking about x equals 2, okay, so remember from our mnemonic, vertical lines have undefined slope and they have x equals equation. So if I graph this line, it is going to be a vertical line through x equals 2. So that means that a parallel line is also going to be an x equal line, right? So the parallel line is going to be x equals something. Well, the x equals something I can get from this point right here, right? So this negative 4, 5 tells me that x is negative 4 and then y is 5. So that means my x equals something is going to be x equals negative 4. So x equals negative 4 is the line that is parallel to this original line that is x equals 2. So in summary, remember to write the equation of a line parallel to a given line. You're going to start off by identifying the slope of the line. Then you're going to use this slope and the given point, xy, to write the equation using either point-slope form or slope-intercept form.